Hello and welcome back to the Alteryx Weekly Challenge with me, Nick Bignell. This is challenge number 48. This is revisiting some spatial warehouse distribution. I think we had a previous challenge along very similar lines. In fact, the use case this time is there are 3 warehouses across the US that supply 26 retail locations. Retailers have product items that are high in demand and as a result out of supply within their stores. Your job as a distribution manager is to allocate as much product as to the warehouses as possible, but there are a few constraints. This is where we differ. A retailer location can only be supplied by the nearest warehouse. Okay, so we need to work out the distance between the two, which I guess is the spatial part. Prioritization of product allocation across the retailers is dependent on required product item need at a location. For example, higher priority is where there is the highest required. Okay, so we all have to sort it in requirement size, I think. So the goal is to allocate as much product from 3 warehouses as possible to the 26 retail locations, assuming they're the nearest ones. Okay. We then have some questions like which store and item have the most unmet supply, which item has the most units allocated across the retail network, which, based on the cumulative distance traveled, items assigned to locations multiplied by the distance traveled, the number of items times the distance, which items collectively traveled less than 400,000 miles. Okay, so let's have a look at the data. So this is the demand. So we've got the store numbered A through to Z. Yep. Then we have the items. Looks like there's 10 items, and then how many they require. Then we have the store, the city, state, and location of that store, and then we have the warehouses, so main, second, and third, and the items and how many of each they have. And then down here we have the location of those warehouses. So first thing we need to do is work out the distance between, first thing we need to do is turn these into a spatial object and then work out the distance. So that's fairly straightforward. So if we take the retail location first and we go to spatial, and then we can create point, because that's what we want. So we want to create a point, and all we do therefore is take that retail location. It's already picked up the lat and long, and we want to create a point. So what that will do when we run it is say that they've got an issue with our directory. Okay, well I've just saved it to a local directory. Now it works. That's good. So let's see what we got. So now we have a centroid point for each of the retail locations. Now we need one for the warehouses. So let's do the same thing for that. Again, it's picked up lat and long, and we will just press run, and therefore we've now got a point for that. So we've got the 2 location points. Okay, so I think we can work out what the distance is between each of the retail and each of the main things, and we can do that by doing a join. So we bring them. For now, just worrying about whether we need to create a record ID or not, but I think we can do that here, so we keep track of what items and the demand is and not get duplicates, because we're going to get duplicates because there's 3 on this side and 20 and 26 on this side. I think 26, 25 and 26. So okay, so let's go to the join. What we'll do is join. We don't actually want to join, we want to append, because we want it for each one. So let's go to append, and that will bring in each of them. So yeah, that's fine. So sources, anything that sources the warehouse. Okay, so we bring that in. So now we have, so we basically want to know what the distance is between the warehouse and each retail point. Okay, and then we can work out which one has the least, is the smallest, and then we can then map that back to the original. So let's bring in another spatial tool, which is the distance. Okay, and so we can just work out what the distance. We need to know, didn't need to know the direction. We want it in miles, and we want the distance. Okay, so we can pull that out, and that's given us the distance between each one. Now we have in the top one, for example, store A has got 620, so the main warehouse is the shortest distance. For B, again, it's the main warehouse. For C, it is the third Colorado Springs warehouse. Okay, so what we want to do is sort by, we probably want to pick the minimum distance by store. What we're going to do is we're going to sort this, and we're going to sort it by the store first, ascending, and then by the distance, ascending. So we get the shortest height one first. So A is the main one, B is bigger, is the main one, but C is Seattle, is the third. So it's now organized it. Now if we bring in a unique, we can then unique on store and distance. No. Unique on store. If we just unique on store, then that will give us the first line for every store, which is the shortest one. Okay, so we now have our 26 again, and we have the shortest warehouse, and it's given us which one is closest. So the main one is on the main one is on most of them, and then we've got the others. Okay, so this is something we can now use to map back to the. So we can then provide the. We can map back to what this store here to show which is the closest, so that we can then look at the warehouse supply for that store. Okay, that makes sense. So let's do now we do a join, and we want to bring in the retail demand, and from now on it's just kind of data preparation. So I'm going to probably fast forward this part. Okay, as you can see, we've now got store the items, the required warehouse distance, the total that was in the warehouse, priority remaining, and the number of items that were delivered. Okay, so now we can start sorting this information into answering these questions. So question 1 is which store and item have the most unmet supply? Okay, so basically we want to sort it, I guess, unmet supply. So it's the difference, I'm guessing, between the required and the delivered. Yeah. Okay. So required minus delivered is a formula we want to work out for that. Okay. So let's do that. So let's call this. What was the field that they used up here? Unmet. Okay. So we create a new field and call it unmet, and it is the always forgetting what fields are called. So it's the required minus delivered. Okay, so let's do that. Run that. Now what we can do is we can, if we just have a look down here, that's a bit odd, isn't it? That should be, so that one, for example, it's because I've written the wrong thing. It should be required minus delivered. Okay, might help if I could double. Okay, we'll run that. Okay, here we go. So here we've got, so here we've got all the different. So if we just sort this by, if we sort this by unmet, we'll get the top one. So sort by unmet, descending, because we want the highest at the top, and run that. Okay, so that, let's just put that in the, so we just want to take the top one so it matches. So just take the first n rows, and then we just want to remove, select the fields we don't need. So what we want is store item unmet. So let's remove everything, deselect, so store item unmet. We'll run that. Put a browse at the end, always forget to do that. Okay, so the selecting skills have let me down. There we go. Right. So on that we've got x9 and 68, and on that we've got x9 and 68. So question 2, which item has the most units allocated across the retail network? So what we're looking for here is the item and the sum for field. So which item has the most units allocated across the retail network? So we want to sort by item and delivered, and that will give us our sum for field. So let's again go here so we can have a look. So let's group by item, not store, item, group by, and then we want to sum the delivered. So if we sum, and we can call that sum full field. Run that. Okay, so that then gives us Click on the right thing. Right, it gives us this, and then I guess we just want to do exactly the same sort. So sort by descending, and then take the first one. Okay, let's see what we get there. That's not given us the same as here. Right, so maybe I'll misread the question. So which item has the most units allocated across the retail network? Okay, so I've grouped by items, and it's just summed the unmet, not delivered. That was silly, wasn't it? So let's get rid of that. It's the delivered we wanted to sum, and we want to okay, run that. That's it. So we now have question 2 answered. So that's good. And now number 3. Based on the cumulative distance travelled, number of items assigned to location multiplied by the distance travelled, which items collectively travelled less than 400k? Okay, so what we want to do here is summarize the do you want to just take the distance times the units? Actually, let's start with a formula. We can just do that. We'll summarize it in a minute. So we'll take, we'll call this, what have they called it here? Total miles. Okay, so we'll call this total miles. Okay, oh, it would be help if I could type. And then that is basically the number of delivered items times the distance in miles. Let's make it a double. Okay, and then what we can do then is sum that total distance. Yeah, we just want that by item. So we want to group it by item. Group by item. Okay, so that will give us all of the items and the distance for each one, and then we sort it again. We can just easily sort it by some total miles. We want the ascending, so we get the top 4, and then we sample the top 4 for 4 items, and then stick a browse at the end, and that should give us the answer. Well, it's not necessarily on top 4. Let's change that. Actually, we don't want to use this. We want to, because this could change. What we want to do is some less than 400,000. Okay, I'll run that. Okay, that's given us the four items and thing. Let's have a look, see if that's what we've got in here. So they've ordered it by, so we can just sort by the. They've also rounded it. So let's just sort by the item. Oh, have I got store in there? Ah, because I'm doing it on the wrong thing. Let's get down here and sort by the item. Oh, well, pickle. Okay, sort by the item. Oh, no, sort by the item ascending, and then we'll just change. We can use a select tool for that, and we can change this from a double to a fixed decimal with 1 decimal place. Okay, so let's run that. And then if we scroll up, to the answers, we've got a different number. Okay, that's interesting. 4, 6, 9, and 10, and 3, 3, 4, 3, 3, 9, 1, and we've got. I'm going to make it smaller so we can fit it all on one page. 3, 4, 3, 3, 9, 2, 1. Interesting. I'm slightly out with the distance. But it's only like a couple of miles or less than. Well, it's 0.2 miles. I wonder if that's a rounding thing. I'm going to say that's rounding because it is really close. Okay, thank you very much for watching and see you again next time.